Hi guys, in this video I'm gonna briefly show you my ARP uh, attack detector project that I've just made and just shared on my GitHub page and GitHub profile, and I will link it in the description obviously. So let's see how it works. For to prove this, to prove my project, I just set up a virtual environment where I have this three virtual machines all running Kali Linux. I have the victim, the detector, and the attacker, as you can see in this network topology. So they are all connected to the virtual gateway that is that has this IP, and that is automatically created by the virtualization software. In this case, I'm using VMware. And all these three virtual machines um, have the network adapter set to NOT, so they can communicate each other because they are in the same subnet. As you can see, they are in the same subnet 192, 168, 154, and these are the IPs. And also they can communicate um, outside the subnet, so through internet. And let's see the virtual machine. Okay, so this is the attacker, and as you can see, it has this IP 131, while this is the victim that has this IP 130, while this is the detector. So I'm gonna close this for now. I'm gonna run it again later. You will see this is the detector that has this IP. So the first thing to do is to go to the folder of my project and let's see. Okay, and let's run the program with this program, this command. Okay, it will start um, a local yeah, we'll start a local server on localhost and with this local port. And at the start of the program, as you can see in the first logs, it builds a baseline, so it will send ARP requests that are broadcasts, as you know, to all the devices in the same subnet. So this is used to map the devices, so to see which are the alive devices in the network. And this is useful um, because the detector has to um, dynamically build the network topology, as you can see here. So this is the IP of the detector itself, while this is 131, the IP of the attacker machine, as you can see here, 131, sorry, while this is the IP of the victim machine, 130, as you can see here. So the thing I'm gonna do now is start monitoring, and as you can see, monitoring is active. And I'm gonna go to the attacker and use a Python script that um, let me launch the ARP spoof attack. This script can be also um, can be also found in my GitHub profile, on my GitHub profile. And this is the ARP spoof .py. I will use it to launch the attack from the attacker to the victim machine. So the first thing is to type the IP to spoof. So in this case, I'm gonna obviously enter the IP of the victim machine, that is 130. Let's confirm it. Yeah, as you can see. And while the second thing to enter is the gateway of the network. There's, as we can see, as we saw before, it is this one, the virtual gateway. So let's put it here. And this script also reminds you to run this to redirect and forward the traffic incoming from the victim. So let's do it. Okay, successfully done, and the attack is launched. Before going to the detector, I'm gonna go to the victim machine. I'm gonna confirm that the attack is effectively running. So I'm gonna do ARP-A to see the ARP tables of the victim machine, and as you can see, we have to look to this one, that is 131 is the IP of the attacker machine, and this is the MAC address, and we will confirm it. It ends with F3FC, and as you can see here in the attacker machine, we have this MAC address F3FC. It's, yeah, and the gateway, as you can see, has the attacker MAC address, so the attack is effectively working. Now let's go to the detector and let's see if the detector detects the attack. And as you can see, it successfully detects the attack. As you can see here, this is the attacker 131 as expected. In fact, we can see this is the attacker machine, while this is the victim IP 130, that is this IP. So the victim IP, the victim machine. So the attack was successfully detected. And if we go to the ARP events page, we can also see this table that is reporting this printing dynamically the ARP events, so the ARP attacks. As you can see here, there is the victim IP, and in this case we have 130, that is the victim machine, and .2, that is the gateway. And this is the old MAC, while this is the new MAC, that, as you can see, if you remember, F3FC, this is the MAC address of the attacker machine as expected, while this is the column for the attacker IP, while this is the timestamp. So just to see when this attack was detected. You can also download this table as GSB. So this attack works perfectly. If I do stop monitoring, it will go in network safe, so it is not monitoring now. If I go back to start monitoring, so monitoring is active. Let's give him it just a couple seconds, as you can see the attack is detected again because it is running. If I stop the attack from the attacker script, as you can see, Control C, this script that I've made, that is my GitHub profile. Also detect the control C and reset the ARP tables, so all the ARP tables now are turned back to the normal states. In fact, as you can see here, we have the 131 with its MAC address, the attacker MAC address, while the gateway has its own MAC address, as expected in a normal scenario. So as you can see, the monitoring is active and the network is safe, and this works perfect. Well, now let's stop the monitoring, and we can say that this attack detection works fine in this virtual environment. This is because all the machines are connected and to this virtual gateway that acts as a virtual switch, and they share common they share the medium, so uh, all the machines inside this virtual environment, this virtual network, obviously can receive and spoof ARP replies that, as you should know, are unicast. So to implement it in a real scenario, we may need some modification. Obviously, we have the detector that has to be the default gateway for the other for all the other devices in the subnet, and this will work in a real scenario too. While this actual implementation is just in a virtual scenario, and but you can just implement the ARP detector program on on a router or switch, a programmable switch, or on a machine, like let's say the detector in this case, that has to be the default gateway for all the other devices in the network. So all the traffic, all the packets passes passes pass through the detector machine, and so the detector can effectively analyze the packets, and in this case particularly the ARP packets, ARP requests that are broadcast, obviously, and especially the ARP replies that are unicast, so it can detect the attack successfully, as it did in this case. So this is just a brief description, a brief proof of how my detector project works, and I hope you enjoy it. If you want to see more, go to my GitHub profile and check it out. Thanks for the attention. Hope you enjoy it.